Good afternoon, or good evening, or good morning, whenever you're viewing this film. My name is Shannon Gracie, and I am a professor at Maricosta College. We are continuing on with Blitzer's Introductory and Intermediate Algebra text and covering section 5.2, which is multiplying polynomials. It is very, very, very important when you are working through multiplying polynomials that you pay attention to what you're doing so that you can remember the process when you learn about factoring, which is in chapter 6. So I might be showing you how to do certain multiplications, especially when multiplying two binomials together in a way that seems strange or different to you because everybody loves FOIL. Personally, I think FOIL is more appropriate for a barbecue than mathematics, but that's how everybody seems to like to multiply two binomials. But in order to learn how to factor by grouping and being a successful factoring trinomials person, you need to know how to multiply two binomials merely by using the distributive law twice. So anyway, I know I'm getting off on a tangent here, but just give me this time and take my word for how this, certain multiplications will make it easier for you later. Okay, so we'll be, using the product rule for exponents, power rule, products to power rule for exponents. We'll be multiplying monomials and then multiplying a monomial with a polynomial, and then we'll be multiplying polynomials when neither one has a single term as a monomial. So here we go. Why don't you get all warmed up by adding or subtracting the following polynomials, and we'll get started with the lesson. Okay. Go ahead and pause the movie and warm up. Okay, let's see how you did on the warm-up. So here, notice that the first one is a subtraction problem. So this will be equivalent to negative 22 times r to the 7th plus 6r cubed minus r squared, because there was nothing in front of these parentheses or, being multiplied on this side of the parentheses. But here, remember, we have to distribute that minus sign throughout. So we'll have negative 2r to the 7th minus r squared, and then minus a minus is a positive 1. So these green expressions are equivalent. And then getting the like terms, and I apologize, let me do this in red. I wrote negative 2r to the 2nd, not the 7th, it's to the 7th. So here we'll have negative 22r to the 7th. We have a minus 2r to the 7th. And then the next term is that 6r cubed. Then we have a negative r squared minus r squared. And then we have our plus 1. So I just commuted the terms so that the like terms were next to each other. Negative 22r to the 7th minus 2r to the 7th gives us negative 24r to the 7th. And then we'll have a positive 6r cubed. We'll have minus 2 of those r squareds, be careful, plus 1. Okay, so here we go. All right, how'd you do? Awesome. All right, so next up we are adding. So these parentheses are not doing us any good. We'll go ahead and take them off. Notice nothing is being multiplied except for positive 1 to these parentheses. So plus and negative is minus 8x to the 4th, and then plus a plus is plus. getting the like terms together, we will have 8x to the fourth minus 8x to the fourth. We'll have minus x cubed plus x cubed, and then we will have a minus x squared. This gives us 0x to the fourth minus 0x cubed minus x squared, which is just going to be, 0 minus x squared gives us a negative x squared, and we're all done. Okay. All right, so here we go. The product rule for exponents. We have seen that exponents are used to indicate repeated multiplication. So recall that 3 to the fourth is equal to 3 times 3 times 3 times 3. 3 multiplied to itself 4 times. Now what if we have 3 to the fourth times 3 squared? 3 to the fourth times 3 squared would be 3 times 3 times 3 times 3. That is our 3 to the fourth. And then times 3 times 3, that is our 3 squared. Okay. So what do we have going on here? Do you see that this gives us a result of, actually we can just do an equal sign. So this will give us a result of 3 to the sixth, okay? But now we want to, generate a rule here. We see that this is 3 multiplied to itself 6 times. But look at this. Do you see that this is also equivalent to 3 to the 4 plus 2? Do you see how we could add exponents when we're multiplying like bases? So here's our official rule, okay? The product rule. So if you have some base to the m power, and you multiply the same base, it has to be the same base, to the nth power, what do you think we're going to get? What's the rule? Good, it'll be b to the m plus n. If you have the same base raised to 2 different powers and you're multiplying, you add the exponents. So here it is in words. When multiplying exponential expressions with the same base, add the exponents. Use this sum as the exponent of the common base. All right, so here we go. Here's an example. And I highly recommend that you use the rule, okay? I know that many of you might already know what the result is, but use the rule so it gets in your mind. So what I mean by that is, for part A, instead of even looking at your calculator, do the rule to say, oh, I have the same base, which is 2, so I'll get 2 raised to the 5 plus 3. This gives me 2 raised to the 8th, and we can calculate 2 multiplied to itself 8 times turns out to be 256. So you go ahead and try part B. Pause the movie and try part B. Okay, let's see how you did. Remember that x is the same as x to the 1 power. So here, do you see we have a common base of x? and they're being multiplied together. So we'll get x raised to the 2 plus 1 plus 4, which gives us x to the 7th power. We don't know what x is, so that's as far as we can take that problem. Okay, the power rule. So we are raising powers to powers. So if we have some base, and it's being raised to the m power, and then that in turn is raised to the nth power, it turns out that you'll get, well, I don't know, what do you think that we'll get? Let's do an example below. Suppose we let our base be, I don't know, should we have our base be 3? Right? And suppose that 3 is being squared. And then suppose that this expression is going to be cubed. So then, actually, I don't want to repeat any numbers, so let's do this. Let's do raise it to the 4th power. Okay? So, here we go. Using rules for exponentiation, do you see that this would be 3 squared multiplied to itself 4 times? So this would be how many 3's being multiplied to itself? 3 to the, good, 2 plus 2 plus 2 plus 2, which is 3 to the 8th. And for now, we'll just leave this as 3 to the 8th. We want to see why the rule works. Now 2 and 4, do you notice something? Exactly, 2 times 4 is 8, right? So it turns out that 3 squared to the 4th power is equivalent to 3 raised to the 2 times 4, which is 3 to the 8th. So what do you think the rule is? Good. We would get, this would be b raised to the m times n. So when an exponential expression is raised to a power, multiply the powers. Place the product of the exponents on the base and remove the parentheses. Okay? All right, so let's take a look at an example. So example 2, simplify each expression. So using our rule here, our base is 4, the powers are 2 and 3, so we're multiplying the powers. This gives us 4 to the 6th, and if you were to work that out on your calculator, you would get 4,096. And notice that going from here to here, we were able to remove the parentheses. All right, part B, this would be x to the, good, 12 times 5. This is x to the, wow, 60th power. We're done. Okay, next up, the products to powers rule. products to powers. So this is a situation when, suppose we have, I don't know, 2x, and it's going to be cubed. Well, we know that we could write this as 2x multiplied to itself 3 times. But we're looking kind of, for a shortcut rule. So do you see, well, what is this? This is 2 times 2 times 2 times x times x times x, right? Which is 2 multiplied to itself 3 times x multiplied to itself 3 times. So it turns out that if you have two different factors being raised to a power, you can raise each factor to that power. Okay? So the general rule looks like this. Suppose a and b are factors, and they're being raised to the n power. You get a result of a to the n times b to the n. So when a product is raised to a power, raise each factor to the power. All right, so go ahead and take a look at A. So for A, using our rule, this would be, I'll put the negative with the 2, so negative 2 to the 5th, and then times y to the 5th. I included the negative inside because the negative is within the parentheses. So negative 2 to the 5th is negative 32, and then we get y to the 5th, and we're done. Okay, you go ahead and try part B. Pause the movie, try part B. All right, let's see how you did. So using our rule, the first factor is 10. We'll square that. Times the second factor. Notice we have power to a power. So we're going to have x cubed being squared. Well, 10 squared is 100. X cubed squared is going to be x to the 3 times 2. I'm using one of those earlier rules, which at the end of the day gives us 100 times x to the 6. Okay. All right, so now we have all the information we need to be able to multiply monomials. So, to multiply monomials with the same variable base, multiply the coefficients and then multiply the variables. Use the product rule for exponents to multiply the variables. All right. So here we go. Oh, sorry, these should be renumbered. A, B, and C. So here we go. We have 8 times x. Notice everything's being multiplied, right? So we have 8 times x being multiplied to negative 11 times x to the 4th. So here's what we do. everything's being multiplied so we can commute the terms, or the factors rather. So we're going to have 8 times negative 11. Those are the two constants, the coefficients. Then we're going to have times x, and then times x to the 4th. Remember, x is the same as x to the 1. So 8 times negative 11 is negative 88. And then we get x to the 1 plus 4. So we get negative 88 x to the 5th. And we're done. All right, you guys try the next two and see how you do. Pause the movie and try the next two. All right, let's see how you did. This next one will be, we'll have 7 times 2 times y cubed times y squared. 7 times 2 is 14. Then we'll have y to the 3 plus 2, 14y to the 5th. We doing okay? Awesome. All right, and then we'll have 2/5 times negative 5/6 times x to the 4th times x to the 7th. Notice that the 5's will divide out. I'll just keep the negative right there. 2 goes into itself once and into 6 3 times. So we will get negative 1/3 x to the 4 plus 7, which is negative 1/3 x to the 11th. All right. Multiplying a monomial and a polynomial, or polynomial, a polynomial that is not a monomial. To multiply a monomial and a polynomial. Use the distributive property. To multiply each term of the polynomial by the monomial. Polynomial by the monomial. Okay, so here we go. 3x squared times the quantity 2x minus 5 gives us 3x squared times 2x minus 3x squared times 5. So notice what I did here, guys, is that each of these parts, each of these terms is like a problem we did in the last example, right? It's just a little more complicated because we had more to multiply. So now this is going to be 3 times 2 times x squared times x to the 1 minus 3 times 5 times x squared. We will get 6x to the 2 plus 1 minus 15x squared, which gives us a result of 6x cubed minus 15x squared. Are we good? So we're combining all these skills into one happy problem. So you guys give B a try. See how you do. Okay. So we'll have negative x times x squared plus negative x times 6x minus negative x times 5. So I distributed the negative x to these three terms. So we will get negative x to the 1 plus 2 minus 6x to the 1 plus 1. Minus a minus is plus 5x. We put the coefficient first. So now this will be negative x cubed minus 6x squared plus 5x, and we're all done. How'd you do? Awesome. Be careful of the negatives, All right, so next up, is multiplying polynomials when neither is a monomial. Right? So here we go. Multiply each term of one polynomial by each term of the other polynomial. Then you gotta combine like terms. So here we go. I'm going to keep this second binomial locked. Okay? So this guy is stuck together. And we're going to split the first binomial. This is where I was saying just try it this way. Try it this way. And I promise you it will help you in chapter 6. So we're going to first distribute the x to the x plus 5. And then we're going to distribute the 2 to the x plus 5. So this is going to give us x times x plus 5 plus 2 times x plus 5, which will give us, now we have to distribute each of these monomials through. So this is just like it was in the last example. We're now going to have x times x plus x times 5 plus 2 times x plus 2 times 5, which gives me x to the 1 plus 1 plus, I'm going to commute these and write it as 5x plus 2x plus 10. Notice that 5x and 2x are like terms, so we're going to get x squared for x to the 1 plus 1. 5x's plus 2x is 7x's, and then we have 10. All right. Why don't you try B, pause the movie, and try part B and see how you do. On your mark, get set, go. All right, let's see how you did. Part B, I'll go ahead and start down here. Again, I'm going to hold the second binomial firm, and then we'll be distributing the 2x and then the 5. So we get 2x times x plus 3 plus 5 times x plus 3. Okay. This will be 2x times x plus 2x times 3 plus 5 times x plus 5 times 3. So just so you can keep track, this here distributes to be this, and this here distributes to be this. So then we'll get 2x to the 1 plus 1 plus 6x's plus 5x's plus 15. We will have 2x squared plus, see the like terms, 6x and 5x combined to be 11x's plus 15. And we're done. Okay. Okay, now multiplication can also be done vertically. And oftentimes, if you start getting in where you've got a trinomial times a binomial like here, or a trinomial times another trinomial, it can get a little bit complicated. So why don't we do an example of multiplying these vertically, and that will help us to combine the like terms. So I'm just going to rewrite x squared minus 7x plus 9, and then we'll have x plus 4. Okay? So first we're going to multiply the x throughout, right? So this x is going to distribute to these three terms here, up here. So x times x squared, so we're going to have x times x squared is x cubed. X times negative 7x would be minus 7x squared. X times 9 is plus 9x. So I've done this first line. Now I need to distribute the 4 throughout. 4 times x squared gives me positive 4x squared. So what I am doing is I am lining up the like terms. 4 times negative 7x is going to be minus 28x. And then 4 times 9 is plus 36. So then, now I'm adding, so we'll have x cubed minus 3x squared minus 19x's plus 36. And we're all done. So just so you can keep track of what happened, this line was x times x squared minus 7x plus 9. That was the result for that one. This line was 4 times x squared minus 7x plus 9. And then this line was the result of combining like terms. All right. So now we get into some of the, more fun, challenging problems, okay? So these are sort of, multiplying polynomials on steroids. So here we go. We'll just work through them together. So starting off, we need to distribute the 3x squared, because remember, multiplication comes before subtraction. So these multiplications have to go first, and then we will combine like terms. So here we go. This will be equal to 3x squared times 6x cubed plus 3x squared times 2x minus 3x squared times 3. Now we have this, so this first result is just that part of the problem. All right? Okay, so now minus. I'm going to put grouping symbol around this and I'll distribute the minus afterwards. We're going to have 4x cubed times x squared and then minus 4x cubed times 5. Now yours might look a little different if you were taking that minus into account right away. Yours is a little different. What I did here, it's only the 4x cubed times quantity x squared minus 5 is what this is in here. Okay, so now simplifying. 3 times 6 is 18. X squared times x cubed is x to the, good, 2 plus 3, which is 5. Plus 3 times 2 is 6. X squared times x is x to the 2 plus 1, which is x cubed. And then here, minus 9x squared. So that is the yellow minus 4x to the 3 plus 2 is 4x to the 5th. And then minus 20x cubed. So that is the finish of the blue. All right. So we'll have 18x to the 5th plus 6x cubed minus 9x squared. I'm going to distribute the minus throughout the blue. And this is what we end up with. Combining like terms, I have 18x to the 5th minus 4x to the 5th. I have a 6x cubed plus a 20x cubed. And then I have a minus 9x squared. So my end result will be 14x to the 5th plus 26x cubed minus 9x squared. Alrighty, part B. Now, here we go. Y plus 6 squared is y plus 6 times y plus 6. And then y minus 2 squared is y minus 2 times y minus 2. Now, I'm going to hold the second one from each of them steady, and we'll be distributing through. So we will get y times y plus 6 plus 6 times y plus 6 minus, and again I'll put grouping symbols, y times y minus 2 minus 2 times y minus 2. So this is equivalent to this, which is equivalent to this. And this is how the second part lines up. so we will have y times y plus y times 6 plus 6 times y plus 6 times 6 minus y times y minus y times 2 minus 2 times y minus 2 times negative 2. And it got a little tricky at the end because notice that negative 2, you have this minus going through both. So just be careful. So this is the yellow. This is the blue. So we will have y squared. We've got 6y plus 6y is 12y, and 6 times 6 is 36. Minus y squared, we have minus 2y is minus 4y, and then plus 4. So this is the blue, but we still have to distribute that minus through, and this is the end of the yellow. So here we go. We will have y squared plus 12y plus 36 minus y squared plus 4y minus 4. So putting the like terms together, we'll have y squared minus y squared plus 12y plus 4y plus 36 minus 4. Y squared minus y squared is 0y squared plus 16y plus 32. 0y squared is 0, so we end up with 16y plus 32. So that was a bear of a problem, right? I mean, might need to go and have a margarita now that you're done with that one. But hold on, we just have one more page. We'll do our application, and then you'll be free to do some homework and then enjoy the rest of your day. Okay, so here, this is sort of showing you why we end up getting 4 terms when we multiply 2 binomials, right? So here we go. You can think of it as, all these different rectangles, right? So here, express the area of the large rectangle as the product of 2 binomials. So if you see the length here, isn't that 2x plus 3 for the whole length, right? And the width, if you see, are these two added together. So that's your width. And remember, area is length times width. So you would get, let me write down, this was our width, and this was our length of the larger. Okay. So the area would be length, which is 2x plus 3, times width, which is x plus 2. And we'll leave that for now. They didn't want us to simplify it yet. Now, the individual areas, so the 4 small rectangles, right? So do you see, for the purple, this area would be 2x times x. This area would be 3 is the length, do you see here? And then what is the width? the width is still x, right? And then this light blue one will have the area is 2x times 2. And this dark blue one, the area is 3 times 2. And what part B wants is the sum of the areas of the 4 smaller rectangles, right? So if we call this one 1, 2, 3, and 4 for the smaller ones. The first one we said was 2x times x. Let's write area equals. So area equals 2x times x. So the area will be 2x squared. The second one, the area is 3 times x, which is ready already. The third one, the area was 2x times 2, so the area will be 4x's. And the fourth one, the area was 3 times 2, so it had 6 units, 6 square units. Now they want us to add them all together, right? So the overall area of the big rectangle is equal to 2x squared plus 3x's plus 4x's plus 6, which equals 2x squared plus 7x's plus 6. And that's going to be in square units. So now our job is to use polynomial multiplication to show that the expressions for part A and B are equal. So we have to take this area and show that we get 2x squared plus 7x plus 6. So let's see what happens. So area equals, I'm going to leave this one together, and then we're going to distribute these two throughout. So we'll get 2x times x plus 2 plus 3 times x plus 2. Our area is 2x times x plus 2x times 2. Looking familiar? Plus 3 times x plus 3 times 2. So we will get 2x squared plus 4x's plus 3x's plus 6. And our area is 2x squared plus 7x's plus 6. And you can see that this matches the last result. They are the same. All right? Okay, so have a wonderful rest of your day, and we'll be learning about special products in our next lecture. Bye.